Hello, this is the final video on the topic of testing for differences between multiple populations. In the previous video, we talked about analysis of variance, which is over 100 years old, as a method to formally look for mean differences between multiple groups or populations. Well, it turns out there is an alternative approach called analysis of means, or ANOM. And ANOM has become increasingly popular because we now have software that easily does it and can provide us with visualization, especially jump. And ANOM was invented to be a visual method and meant to be easier to understand given ANOVA is somewhat abstract and can be difficult to understand without substantial explanation. So ANOM, as you're going to see, again looks for differences among groups, but does so in a different manner. First, ANOM does not make comparisons between groups. It simply looks to see for each of the groups if they are significantly higher or lower than an overall grand average. And the way the method works is you get a visual display in which there are upper and lower decision limits about the grand average in any group that has a mean plotting above or below the decision limits is considered different. So visually, it's actually a very easy method to understand. And I will not go into the mathematics of it. They're somewhat described in Jump Help. They're not difficult. It's just, I don't think, necessary to our discussion. You can also Google the topic. There's a lot of literature on it. And analysis of means has enjoyed quite a renaissance recently, as I mentioned. And as a note, the method was invented by a fellow named Dr. Lloyd Nelson from Londonderry, New Hampshire, and he did this in the 1950s, again as an alternative and easier to understand approach looking for differences among multiple groups. So I'm going to go ahead to jump, and I think I'll use the anodized parts data that we discussed in the ANOVA section. And this is a different example than is in the statistical testing 2 notes. So again, we have 3 groups which have color ratings, and the response is thickness. So again, I go to Analyze, Fit Y by X. I'm comparing 2 columns. So color rating is X. It defines the groups, and thickness is the response. Okay. So previously we did ANOVA, and using ANOVA, which you do have to invest more time in understanding the approach, based on the p-value, we decided that yes, there appear to be significant differences among the groups. And at that point, you could do multiple comparisons to see which are different. With ANOM, you simply click on the report menu, Analysis of Means Methods. Notice it also does a test for equal variances, which I'll illustrate for you in a moment. But first, I'm just going to do traditional analysis of means. So the grand average right here is 0.951. The upper and lower decision limits are varying for the groups because the sample size for each group is factored into the calculation of decision limits. So any groups plotting outside of the decision limits are considered different, and we can see all 3 are different. In fact, the ANOM helps us see how truly different smutty black and purple black really are. They're strongly different. There's a very big difference between them. In the report menu for analysis of means, you can actually show a summary report, which is going to tell you the obvious: all 3 groups are significantly different. But notice how easy this is to interpret. It looks a bit like a control chart. That was Lloyd Nelson's motivation. but it's entirely visual, and the person reading the chart does not have to know a great deal of the underlying computation and theory to understand ANOVA, although the two often will give you the same conclusions. But analysis of means, again, is increasingly popular because of its simplicity. And then also, I mentioned earlier the equal variance assumption, and it does appear that smutty black may have more variation than the other groups. This would make sense because smutty black means there's much more thickness, therefore there's a larger range over which the readings could vary, and that would indicate you may see a higher variance. So I'm going to click on the report menu and go to equal variance test. Sorry, I'm at equal variance, clicked on the wrong option. Okay, unequal variances. Again, I recommend Levene's test, and look at the small p-value. Levene's test overwhelmingly rejects the concept of equal variance, and in fact, looking at the plot, you can see that smutty black appears to be significantly higher than the other two. I also want to point out the equal variance assumption is actually a mild one that is hopelessly overemphasized in practice. In general, you need to see a difference in variance of a factor of at least 10 before this even becomes an issue. So in many cases, many statisticians really don't focus on the equal variance assumption, but I will show you how it's done. And there is an unequal variances ANOVA, sometimes called Welch's method. It's a natural extension of the unequal variance t-test. And again, you'll almost virtually, if there's really a difference, you'll see it no matter which method you use. So the variances are different. It does not change our conclusions. And then finally, I want to go back to the analysis of means menu, and they have a visual Levene's test. This is another nice use of analysis of means, and notice that purple black is significantly lower and smutty black is significantly higher, but overall normal black, which makes sense with the three groups, falls basically in the middle and is not considered different. So this is a nice visual way of showing purple black, which is much thinner, also has much less variation. Makes sense. There's a smaller range over which to vary. And smutty black is significantly higher in variance. Again, makes sense because there's a wider range over which readings can vary.